Hello, we are joined by Harris from Think Silicon. We've got one of those moments. We've got one of those moments where we're going to talk about something absolutely fun and absolutely disruptive. So imagine you're Ethan Hunt in Mission Impossible, and imagine you're hunting down the baddies, and imagine that you've got to be able to talk to your team locked away in a van somewhere, and you're looking through your glasses, and they're giving you information, and you're giving them information, and you think, oh, that's all made up, and then you come across Harris from Think Silicon and Applied Materials, and he says, no, you can be your own Mission Impossible, you can be your own Ethan Hunt. Explain, tell me what you've done and how you've done it.
Yeah, exactly. This is exactly what we're developing here at Think Silicon Applied Materials. We are enabling Mission Impossible technology. The way we're doing that is by developing a very tiny IP called NEOX GA100. And what it does is bringing together graphics display and AI enabling. Now, we're really proud about that because it's really a unique technology being that tiny and that small and being able to offer AI capabilities at the edge device at low power and limited resources environments. And at the same time, if you want, you can also use our IP to display pretty competent graphics and graphics requirements.
So let's just talk about, we've had some fun with the whole Mission Impossible idea, but the actual reality is what you've been able to do is take your heritage of the GUI and then you've been able to combine the AI, because you can't do this being able to see the image on the glasses unless you combine those two things together. So explain how you've been able to combine your heritage with the GUI and AI and the skill that you've applied in order to make that happen.
Great, yeah. So guys, let me explain how we are basically utilizing our inheritance in the GUI and how we combine it with our AI capabilities so we can bring everything together. So our proprietary IP technology is based on a multi-threaded architecture, which is really the enabler of the whole thing, because using that we can dedicate some threads into the graphics display and some others into running AI inference. Now, the way we're doing this so efficiently is basically based on the fact that AI and graphics are extremely efficient when they are getting deployed in our IP. What I mean by that is that we are really wasting no clock cycles when we are running AI or graphics. Because we really want to be 100% efficient and utilized, so we can get rid of the workloads of graphics and AI very quickly, so we can change between AI and graphics and you can never tell the difference. Because remember that a really important feature of the whole thing here is that we're using a single core NEOX GA100. We are not using a multi-core architecture to run graphics and AI. We are relying on a single core.
Yeah, and is actually, I mean, the real skill in here is having that what you call that multi-thread environment, because otherwise, if you've got something like a pair of VR glasses, you just don't have the room, you just don't have the power to do that. So the only way you can bring virtual reality onto a pair of glasses and for it not to be very, very clunky and slow is to be extremely clever, where you run the two things together. Well, they're not actually running together, they're running one after the other, but you've got to do it really, really efficiently so that the user isn't able to pick up the difference. That's essentially the problem that you solved.
Exactly.
Excellent. Okay, so now there's one other piece to this story, isn't there? Because there's one thing solving this very, very clever part between the GUI and the AI, but you can't. You also have to combine that technology with the technology that Applied Materials brings to the story, which is the glass, which is the other part of the system that you have. So could you just talk about the glass now and explain how you combine and how the team has combined to create both the glasses and the virtual reality to create our Ethan Hunt moment with Mission Impossible?
Yeah, Guy, let me now go through the smart glasses and waveguides technology and how we're using it. So Basically, we're part of Applied Materials, which is a big organization, and as you know, mostly develops materials. And one of the proprietary technologies that we're really proud is the waveguides technology that we have developed. Now, using that waveguides technology, we can actually display stuff on smart glasses. And when we saw that we have that ability in-house, we said that, okay, this is an amazing cool feature that we have actually developed ourselves. And we thought that we can combine it with our IP, which basically displays stuff on screens, so on smart
Yep.
glasses, and also running AI very efficiently on very restricted environments and areas.
So Harris, just explain. You're in a very small, the constrictions of where you're going to put this technology is very restricted. It's literally the very small space that you've got in the glasses and the stem. So all of this has got to be done incredibly efficiently. Otherwise, the user experience is going to fail. And if the user experience fails, the whole thing fails.
Exactly.
So this is, and you have to have the whole package, which is the glasses, the efficient use of the GUI and the AI, all working incredibly efficiently in a very small constrained area to give the user the Ethan Hunt experience where he's interacting. So why don't we now just look at the demo and you can show us how efficient and how amazing this is.
Thus, this is the technology that we have developed, and if I bring the camera really close to the lens, then you will be able to see that we're actually displaying stuff right now.
Yep.
You might notice that something just changed on the screen that you are seeing right now. So basically what happens is that I spoke one of the keywords that are interacting with the menu that you're seeing now, and we can actually play around with it. So if I start saying keywords like left, right, up, right, right, go, left, go, up, left, go, up, right, up, left, right, right, go, go, up, right, right, go. Here you notice that we're actually controlling the car infotainment menu using voice commands. And the really cool feature of it is that the whole menu is getting displayed through the lenses of the smart glasses.
Okay, so Harris, we've just seen that demo. The real-time response is remarkable. The AI is literally listening to your instructions in a way that a human being wouldn't even realize that there is a response time. That is almost like human being response, isn't it? So that's all down to this multi-thread part that you've done, which is where the GPU is just interacting simultaneously with the data and the AI at the same time. That's basically how you've cracked that.
Exactly, guy. Yeah, this is how we do it basically. We are relying on a proprietary multi-threaded architecture, which allows us to dedicate some time on the display of graphics and some time on inference of AI workloads. And each time we are really efficient in utilizing our underlying hardware. So when we are working on the AI, then we are utilizing almost every clock cycle dedicated to run AI inference. We waste no time. That's why we're able to finish the workload and go back to graphics and back to AI.
Yeah. So it's that management of that clock cycle, and that's that management of those threads that enable you to do it. So I still maintain that if you're going to have things like these VR glasses, if you're going to have that AI so you can talk to your glasses, it has to be in that real time, and the user experience has to be seamless. So you've just given a demo there where you can absolutely see in a very constrained space. You've only got the stems and the frames of the glasses to get this electronics in. And then when you actually get the user experience, it's in real time, it's immediate. It's the user experience. Because I'm sure there are less good, cheaper, more inefficient solutions to VR glasses.
Exactly.
No doubt about it. Exactly. No, there's no doubt about it. But I maintain that unless you get that instant response to your voice commands, if you sit there and go left, yeah, can you go left?
Exactly.
Yeah, go left, and then it happens. It's all pointless.
Exactly.
It's got to be go left, click. It's the real time. It's the real time response.
Exactly.
Tiny bit of electronics that you've got in your glasses. There's no space. It's not like you're wandering around with a phone.
Exactly.
You've got sort of this tiny little constricted space to get the electronics. So unless you're clever, you're not going to get the user experience that you need to make virtual reality glasses work.
Exactly, Guy. And the story here is that our IP, our NEOX GPU, is based on the principles of our existing and market-proven IPs called NEMA series, and these are well known for being extremely low power. So we usually deploy them on smartwatches, and they can last for a week, 10 days without having to charge them. So we were really careful to maintain that principle and be ultra low power. So when you deploy our IP on the smart glasses, then you will be able to go without charging for many days. And we don't have to worry about charging because we are very strict when it comes to power management and power budgeting. So we don't have to worry about running out of power.
Excellent. Good answer. Ethan is safe. It's mission impossible accomplished, Harris. I think we can say that. Thank you.
Exactly. Perfect. Great, guy. Thanks a lot.